Hello and welcome to day 2 of the Update Your Game Challenge. I'll go ahead and share my screen. Okay, so yesterday I think we came pretty close to resolving the scores that were out of sync. Let me just start up the signaling server. Matchbox. There we go. And then here. Yeah. All right. So yeah, I'm just gonna go to see, okay, really quickly. So this is what we did yesterday. We added the relevant systems in the GRS schedule, and we added the rollback component to the score, and a few other things, but mainly that was the part we were missing. And now the issue we're having now is that um, the game crashes on startup. Basically, there's an error that says that there's a conflict in the order of execution of the systems. Let's see over here, which makes sense because like it has no way of knowing which one needs to run in which order, because these are using the same resources. So like the move system is modifying the transform, and then inside the update scores when it detects the death, well, the score is going to be based on when the player died, and that would be slightly different whether player moved before or after the score was calculated. So I think there's a conflict between these two, and also between the frame system and the update scores. Yeah. So we have the inset and in schedule that we can use to kind of order these. Also, the other tool we have to deal with this is like we did before, because we ran into this situation before when we were doing filtering. We actually had to specify like we want players without enemies, just so that there's no overlap between the queries. So yeah, so those are the two things we have here. Now, for this case, this is not going to help us because there is overlap, and there needs to be overlap because yeah, we're actually accessing the same things as before we're not. So that's why we could deal with this way. So yeah. So if I go back to the main here, we're gonna have to yeah, work around this here by changing the order. I mean, telling it what order it's gonna be. Right now there's no order, so all right. A little bit similar to here, where they have a state in lobby state, and then there's an update, an exit, an enter. So similar in that sense. Right. But I think we need to use this schedule. Um, yeah. So let me just take a look. Okay. TGR schedule. It's just an empty struct and TGR schedule label. So, yeah, what I'm gonna do, I'm gonna look up a little bit of documentation about this. I had a quick look yesterday, but didn't find it. But then later on, it occurred to me that a lot of the updates, um, like when this was introduced, it usually comes up in a blog post and not so much in the learn section. So if we go to, yeah, it would usually be in like in the news section and like one of the version updates. I don't know if it's 0.10 or a little older, like maybe 0.9 or yeah, but we'll just skim through and we should find, okay, here we go, 0.10. All right, so if we scroll down to this section, it'll explain how to do it. Okay. Yeah, because this used to be done via what they call stages, but I guess that's not necessary anymore. Okay. All right. Just kind of introducing the idea here. Okay, single unified schedule. I never know if I'm supposed to say schedule or schedule. Anyway, have you ever wanted, okay. Yes, exactly. That's what we want. We want to specify system A runs before system B. Okay. Um, all systems within a single schedule are now stored in a single data structure. Okay. All right. Adding system. Okay. Add systems. Um, by system by default runs in parallel. Okay, this is how it used to be done. But now you can compress. Oh, there we go. Okay, so we just have to do dot before or dot after. That is a lot easier than I thought it would be. Okay, we can also chain them. Okay, I like this even more. All right. Mhm. Okay, so you can kind of layer this as well. And I think that's all we need. I'm kind of curious to see what else here. Um, okay, so the sets are they're named collections. Okay, yeah. So it's not this, it's really the schedule that we need, the set. It's interesting, but um really what solves our issue here, I'm gonna use chain. All right. Yeah. So if you're ever if you're ever struggling to find documentation about something in Bevy, keep in mind it's good for sure going to be in the news. All right. Um, oh yeah. Okay. So in the main here. All right. So go back and see add systems, and then they have a tuple in there. Yeah. Okay. That's a tuple. Then we have dot in schedule. Do we have, okay. I guess we just do dot chain dot in schedule. I saw within the tuple you can do before, after as well. Yeah, okay. All right, let's try it. Okay, so the move first, or is it the update for it? Well, these two aren't connected, so the order of these two don't matter. But I think I would still do the update frame first. Then we move, then we check if there's a death and we update the scores. All right. Now let's run this. Okay. Here's the URL. Okay. Pull these out. And okay. Let's see. Make sure we can see what's going on here. All right. So let's make someone die and make sure. Yeah, look. Okay, so based on the order we set this up, the score does not go down to 0. It goes down to 1. Because by the time it calculates the score again, the score is calculated, yeah, based on the last frame that the player died. And so by the time, yeah, it's okay. I can fix that. But yeah, the scores are in sync. Awesome. Okay, so let's fix that real quick. Let's see. I mean, I guess I could fix that by making the increase frame system last. Updates. Okay, hold on a minute. So calculates the score first before the player dies. Was that it? No. Update scores. Yeah. Increment the score, trigger death. So frame count frame. These are in the same system. I'm not sure why it's 1. If, oh, okay. Yeah, all we need to do is change the order of these. Because it updates the score before it knows that it's dead. Right. So yeah, this will solve it. Now this will set the last death frame before this runs. So then we should see the 0. We'll have to reset this once it's done. Or maybe it'll reset itself on its own. Yeah. All right, so now I should go down to 0. There we go. All right. So the scores are in sync. Now let's make the enemy move. Okay, we'll have to create a new system. And I think I want it close to the cube move, player move. Move system. All right. And it's gonna maybe be similar to this, or well, without the inputs. But we're gonna want to query the transform on the enemy. Definitely we want the rollback. The enemy, all enemies have rollback, but yeah, this is definitely a good thing to have. Just in case you forget to add the rollback, I guess that would still be an issue. Okay, I'm seeing this allow dead code everywhere. I'm not sure why. But we don't have it on our systems and it's working fine. So yeah. Okay, so I'll go ahead and copy this. It's not going to be that similar, other than just moving a transform. Definitely the inputs are useless for this. Yeah, and call this very enemy. Yeah, the enemy has rollback. Move cube system. Move enemy. Okay. And I guess we could add that right away. Move with the player and then remove the enemy. Yeah, should the enemy move after the player? It doesn't matter too much. All right. So transform velocity. Yeah, we'll move it in the same way as the player. We won't just teleport it, but we'll use the velocity to calculate the new position. Which might be actually quite nice because then it'd be easy to update the speed of the enemy. Maybe we can have the speed based off of some logic. Okay, so I think I want the enemy maybe to kind of move randomly. And when someone is, well, maybe not randomly, but maybe have a certain pattern or something, and have like a different behavior when someone is in the process of setting a new high score. When they've already beat their high score, but they're not dead yet, then maybe the enemy tries to kill them a little bit harder, like tries to target them. So if we do that, we'll also need a query for the players. We don't need to change the position of the player, but we do need to know where they are. I don't think we need to know the velocity of the player. We just want to know where they are. Yeah. Again, this rollback is kind of redundant because all players have, but yeah. Transform. Okay. Not mutable for this. So first, let's just move the enemy normally. And let's query the same way as the player. And query, mutable transform, mutable velocity, and yeah, we don't need the enemy. oops, underscore flat. And I'm going to name these. Be a little bit easier. This one, velocity. And actually, let me make sure the enemy actually has a velocity because the player for sure does, but I don't remember if I added one to the enemy. Plane enemy. Yeah, I don't see the velocity here, so let me copy it over from the player. Just velocity default. And I think that's all we need to do because velocity is already added as a component. It's synchronized. So here. Okay. And for the player, they're setting the velocity first. It doesn't look like the player speed is actually normalized, so maybe no, it's not normalized, I think. And so well, maybe it is actually in the end, or that's only how it's only constrained. But if you're not going at max speed, I suspect you can go a little faster by moving diagonally. Anyway, for our case, we're just gonna, yeah, velocity, I guess, has a vector 3. Here's velocity. Okay. So the velocity is a vector. So it's direction and a magnitude as well. Okay. I'm in the wrong file. Okay. And we're going to apply the velocity this way. And then constrain it to the plane. Yeah, we probably need to constrain the enemy to the plane as well, right? So, or we could have some pretty funny behavior. I mean, if we don't, that might be okay too. Maybe it goes off and then comes back. But we'll do, yeah, we'll constrain it. And it's probably good to constrain the enemy speed at some level. We'll have a different max speed though, but yeah. Well, to start off, maybe we'll leave it the same. Slow down, friction. Oh, this involves input, so let's put this in first. And this is all inside of that loop. We'll do this for every enemy. Okay. And yeah, all of these are referencing T and V. I'll just leave these to T and V. It'll be simpler. All right. And so instead of using input, we're gonna have a target. Maybe target the closest. We'll target the closest, but if someone is making a high score, we'll target them instead, even if they're not the closest. Yeah, that'll be the logic. So target, that means we need to access the score as well. So need a reference to the player's score. So the target here, that's going to be a transform or a position. Like we're going to move towards the position of the player. So yeah, that'll be the target. So I'll figure out the target here and let's see. Okay. When for the player movement, the inputs are just changing the velocity. If we have a target, the velocity will basically recreate kind of something similar as the inputs, but it'll be based off the player's position. Yeah. And maybe we'll play with the friction a little bit. Maybe we'll give the enemy less friction so that, it kind of skids past, when you're kiting the enemy. So it's not, so that you can kite it a little bit, but we'll tune that once we have this all in place. I'll call this target transform. And I'll make it mutable. Do I need to? I don't. That target transform equals okay. I'll do it inside of I can do this inside of, what is it, if let or let if. If what do we say, the score? Oh yeah. So first, okay. First I need to iterate through the players, check the scores, and make sure, like check whether there is a player that is in the process of creating a new high score. So player query. We're not mutating anything here, so enter, and we're gonna have transform player not mutable, and the score. The score is the only one we need to access, really. So the score of the player. Oh, we do need to transform. Transform. All right. So yeah, it's not gonna be target transform. It'll be target position. Target position equals I guess the default. I'm not sure what type is being used for the position. It's probably vec3. Yeah, vec3. So like a vec3 new. No, maybe it doesn't have a new function. Maybe it's neat. Maybe it's default. Yeah. So we have a default position, which is 0, 0, 0. All right. I'm thinking, so like the enemy is actually a 0, 0, 0. So that sphere is kind of like underground. And the players, they're not on that same, they're not at the same like height. They're on top of the plane, whereas the enemy is like inside the plane. Yeah, so we might have to change. I like fix that a little bit, but we'll do that later. All right, so we'll check the score. If score dot score. Was it score dot current is greater than or equal to? No, not equal, because everyone starts at, well, yeah. If the score dot current is greater than score dot high score, then they're going to be our target. Target position equals transform dot translation. Yeah. Okay. And I guess if there's multiple players that are being high score, it'd just be the last one. Unless we tell it, to prioritize the closest one or something. But yeah, so if someone's beating a high score, they become the target automatically. And then if not, then we want the closest. So we need to check the distance, closest position, nearest position, nearest target. Okay, nearest target position. All right, so we need to reference T. I'm gonna rename these to like player transform because we have an enemy transform here. It's just T, but um, I guess this gets too messy. All right. Um, let's see. Okay, so if um, if the player's position is closer to the target position, to the nearest target. Okay, yeah. So I'll check the distance between them, right? So I have T for the enemy's position, and I'm gonna, at least for this, like I'm just gonna set it in a variable here. Enemy position equal T dot translation. And maybe I should be calling these translation instead of position. If not if that distance equal enemy position dot distance with player position, so player transform dot translation. So that's the distance between the enemy and the player, and I need a distance between the enemy and the nearest. Nearest target distance, player distance. All right, and now if the player distance is less than nearest target distance, then we update the nearest target distance, the nearest target position rather, to be the player position. Player transform dot translation. Okay, so here, nearest player position. And here, yet. I guess high score player, high score making player, position, high score beating. All right. Now, outside the loop, I have to decide between these two. Because in here we just still don't have all the information. And so, yeah, I need to know whether there was a, so yeah, this is not even really target position anymore. Let me rename this to high score beating. It's kind of long, but high score player, high score beating player. Oh, that didn't work. Score beating player position. Right. Yeah, it's pretty long. Yeah, okay. So now the target position will be the high score beating player, unless there is no high score beating player. And if there is none, sure, this would be a vector 3 default, but also maybe a player could be at that position. Might be difficult to be exactly there, but I don't want to have, well, yeah, that might create a glitch. So I'll create a Boolean. Could probably make this shorter, but this would be okay for now. There is a high score beating player. High score beating player. There. So, okay, if there is a high score beating player, then it's going to use this. Else, use the nearest target position. And let's format that. All right, so we've got our target position. And we're going to apply velocity to that direction. To the direction of that target position. Moving toward, well, technically it's applying velocity toward. And we're going to do really similar to how the, okay, do we have this slow down? I guess the enemy won't slow down. No, if input up and input. Okay, so I think these constants correspond to, yeah, this is basically an enum, but created with constants instead. So I guess input is a U8. But yeah, this is if up and down. So if you're doing both directions, okay, I didn't know that. But the player, if you do opposite directions, it will slow you down. All right, so we don't need to slow down. We just kind of need this. Well, it's not going to be the same, but um, so this section would be apply velocity. And so we've got let's see. So yeah, our calculation is going to be different because we have a direction already, and that's the position that we're heading towards. B minus 6. So like the target minus your current position, pretty sure. Let direction equal from A to B. Yeah, A to B, yeah, it's B minus A. So from the enemy to the target, then it's target minus enemy. So target position minus the enemy position, that's T dot, we actually have that in the variable. Okay. Target position dot enemy position, that's our direction. And not quite, because this direction depends on the distance. So if we truly want just the direction, we have to normalize it so that it has a distance of 1 on this vector. Normalize. This should be it. Yeah, and yeah, I'm seeing normalize or 0. So yeah, I don't want anything to be able to panic. So I'm going to do normalize or 0. I don't really like when libraries have functions that can panic. I prefer them to return an error, but we do have other options here. Good thing that I took the time to read that. Right, normalize or 0. I mean, yeah, it's technically possible that the player would be in the exact same position as the enemy. Um, though unlikely, because they would probably die before, but we're not resetting the player position when they die, so yeah, it is. All right, and I have to make sure to remember because the enemy is going to gradually rise up through the floor because it's not centered at the same y height or z. I'm not sure which direction the camera is facing, but yeah, based according to our plane. All right, so that's our direction. It's normalized. It could be 0. We have to keep that in mind. If we, yeah. So direction. So we're gonna multiply the direction with our movement speed. For now, let's use um, the same movement speed as the player. Well, yeah, I'll just call this move. And multiply it by movement speed. Can I do times equals? Well, move is a keyword. So enemy move. And we don't really need a variable here because we'll do it directly on the velocity. Direction times movement speed, and we'll do v equals or plus equals okay, we can't do plus equals because v is a vector. We have to do it on each axis. Looks like, yeah. So yeah, maybe I just call this speed. Speed equals, and then we'll do. I mean, it's not really a speed. It's a. I mean, yeah. Okay, v dot x plus equals speed dot x. Y instead. All right. So why we're always adding here, and here it's subtracting in some cases. This is because the movement speed is just always a positive value, but our direction here, because we calculated like this, it can be negative in the first place. So negative multiplied by positive, we can have a negative. I really need to rename this. It's not a speed. I'll call it like movement vector. Movement vector. And it's not the direction because it has a length based on the speed. So yeah. But yeah, this should get our enemy moving. Okay, we don't need all this input anymore. Yeah, let's test this. And yeah, the enemy is going to rise up through the floor a little bit. We'll fix that afterwards, but first let's make sure that we have the behavior that we want. All right, here we go. I think we can probably use our existing ones. Yeah. Oh, something happened, and that's probably the same issue as before. Do we have we must have two systems accessing the same stuff at the same time? I thought we added these in an ordered way. Move enemy, they should not be running in parallel. Yeah, let's check the error. Okay. Let's see. Reachable. Conflicts with the previous system parent. Okay, so within our same system. Okay, yeah. So this is okay. Within our enemy move system, we're iterating through objects that could be part of this loop. And so we're accessing, two different references to the same thing, potentially. So we want to make sure that this is without enemy. um, like we did before. With rollback, without enemy. And we want the same thing for the enemy. We want to make sure it has no players in it. It's not that there is a player where there is an enemy in it. It's just that there could be. So now, yeah, okay. Yeah, so these kinds of errors, maybe one day we'll have them at compile time, which I would love, because this could absolutely be known at compile time. But for now, we have to use the console. Okay. All right, we have scores. The enemy's not moving. Scores are still working as expected. But yeah, enemy's not moving at all. So maybe I should check if there's an error, just in case. No, these errors are from before, right? Wait. Or not? I didn't see this error before. Okay, it looks like we have an actual runtime error. Okay, why are the scores not updating that? Is that just because I'm in full screen? Maybe I'll refresh them both. Make sure. Doing well. I can kind of see like the speed here. Oh, something is having some frequent issues, maybe. Console. Okay, no errors, so this one's not actually an error. Okay, so then that means we have a logic error. So move enemy, apply velocity v dot x. Okay, this might be, I mean, shape cube to plane. Constraint velocity. Am I applying maybe a velocity that's too small? Movement speed. When our movement speed is being multiplied by a vector, by our direction. Yeah. I think it's more likely maybe towards the end that we actually apply the translation. So we apply the velocity here. Are we an enemy? Of enemy, yeah. We're applying v dot x. But I wasn't even moving a little bit. Constraint cube to plane. T dot translation of x. Okay, so it's just, yeah, this doesn't even apply because we're not at these positions where we need to constrain. So, oops, I need to do that. Yeah, I'm not sure what's wrong here. Oh, looks like they lost sync. Is it maybe when we're checking for high score? Maybe because the score is exactly the same as the high score. Let's see, when someone beats their high score, will it trigger something? Nope, still not moving at all. Maybe we forgot something. Is the enemy being synced? Well, the enemy doesn't need to be synced, but it's rather the transform of the enemy, the velocity, and that's it, right? Well, for the player, we have the input. In this case, the input is just based on the player position. System, we have the move enemy system here. So maybe it's useful if I log the velocity before applying it, so I know what that is. Because if the target position was the enemy position, which like incidentally, the enemy is at 0, 0, 0. So if the target was still at 0, 0 after all this, then we'd have a direction of 0. The movement would be 0. It wouldn't be going anywhere. So that might be it. So if if we iterate through all the players, I mean, for sure, there's going to be at least one player, right? See, players, they all have player, they all have score, they all have transform, right? Let me just confirm that. The players have score, they have a transform, and they have a player. Player, score, transform. Yeah. So enemy query, transform velocity, and we're not using this one. Transform, using player and player swap. Kind of like having the unused ones at the end, so could swap this around, but that's not the issue here. Let's just do it since we're here. Probably forget later. And then where's the player query? Player query. Move the score first. Right. Just to confirm that we have everything correct. Transform score is score. Okay. But yeah, we still haven't solved the issue. I mean, I know for sure there's players, and if at the beginning of the game the players haven't joined yet, or maybe they're not loaded yet, they don't exist, and this is still running, it should not cause an issue. I mean, the enemy wouldn't move, but once the players are here, it would at least have the nearest target distance. Enemy position that distance. Between the two, if the player distance is less than the nearest target distance. Oh, I know what's wrong. The nearest target is at the enemy position, so I always assume that there's something really nearby. However, when someone's beating the high score, it should have at least been using that position instead. The high score beating player position, which is being set here. So it should have been moving when a high score is being beat, but at least the nearest target for sure, this cannot be default. It has to be a position somewhere that's bigger than the plane. So, do something like, how big is the plane actually? Is there a plane size 5.0? It doesn't matter what the value is as long as it's bigger than the plane. So I'll do plane size, I guess. You know what, plane size, the plane is centered at 0, 0. So I'll just do plane size, which will be like twice as far as the edge of the plane. X, Y, Z. Okay. Anything that's basically far enough that any player will always be closer to the enemy than this. And maybe there is a Vec3 max or something. Oh, there is. Okay. No, never mind. That's for, what is RHS? And notes and values for each element of self and RHS. RHS is, I don't see RHS in here. Maybe max is not what I think. Oh yeah, vector 3. I mean, vector 3 is F32. I could do F32 max. Again, though, I'll just do this just to avoid any kind of potential issues here, because I am using the target position based on, like, if it ever actually didn't have players and it tried to go here, I'm calculating the speed, like the velocity based on the position, like the distance to the position. Although we're constraining it, so we should be fine. Yeah. So maybe that'll be a little bit more intuitive. So like F32 max. That's not what I want. I don't want like the max between two numbers. I just want the maximum value that it can have. Now I have to look that up. Infinity. Right. I think it's infinity. Yeah, for a float, maybe infinity is actually, yeah, that's what I want. I think this is not truly infinity, but it's as far as an F32 will go. All right, so that should solve that. But I'm still a bit stumped here because if there was a high score beating player, then it should have been targeting the high score beating player instead of the nearest player. But yeah, high score beating player. Okay. I'm just waiting for, oh, it's already started. All right. Okay, there we go. A bit of funny behavior because the player's position is not being reset. Wow, the enemy is really fast. This is kind of hard, which is cool. Yeah, it can't go any faster than me. So as long as I'm careful, it's really fast. Yeah, you can kind of get it to target another player, which is kind of cool. Okay, so yeah, that's gonna be all for today. And yeah, so tomorrow we'll make the player's position reset when it gets killed. Maybe we'll fine tune the enemy speed and make the speed change based on maybe how high the scores are. If the players get to a higher score, maybe it gets more difficult, but at the beginning it should be a lot easier. Yeah, so we'll probably look at some of those things tomorrow. All right, well, thanks for watching. And if you enjoyed this, like, share, subscribe, and yeah, so have a great day. Thanks. Bye.